Let's take a look at how to perform a paired t-test within StatCrunch. So this is the heart rate dataset linked from the lesson. If we click, or what it shows us is the subjects, so the names of the 10 individuals we sampled from, the heart rate before taking a drug, and the heart rate after taking that drug. So we click Stat, T-Stats, Paired. We can select the samples in before and after. Okay, and we want to save the differences, and we'll see why in a moment. So the save differences is going to give us the output of the difference between our before and after. Now when we click Compute, we're going to get a column of the differences. Note here that these differences are positive. That's because it's subtracting in the opposite direction of what we did on the previous example when we worked this by hand. It does not change the interpretation at all. All we have to be aware of is that the difference is going in the opposite direction. So here, a positive value means that the before is higher than the after. So it also gives us our sample difference. This is the mean we calculated before, the standard error, the degrees of freedom, our t-statistic, and the p-value. All of these match what we saw before. This very small p-value means that we are unlikely to see these data by chance if the null hypothesis is true. Therefore, we reject the null hypothesis. Importantly, I want to show you what happens if we do this a different way. If we go if we go Stat, T-Stats, to sample with data, select our befores and our afters, click Compute. Note here that we get a very, very large p-value, 0.3232. This is because it's not taking into account differences between individuals, which means we're losing some of that information. Now if I close that, we can also use this to calculate a confidence interval. So this is the appropriate test. We click Options, Edit. Down here, I'm going to uncheck Save Differences, just so it doesn't keep saving those differences. Check Confidence Interval, change the level to 0.90, click Compute. And now we get the lower and upper limits of our confidence interval. So this again means that we have a 90% confidence that the true population value of the mean difference from before to after is somewhere between 1.33 and 4.26. It's important to note here that those differences are positive because of the order that these are subtracted in. So a positive value here means that the before was higher than the after. It's important to keep in mind when analyzing and interpreting these data.